Okay, so the cotangent function looks an awful lot like the tangent function, only notice that it's going a different direction. And it doesn't straddle the y-axis. There's an asymptote at the y-axis. Couple of things you can see now is that, clearly we've got a midpoint. If the amplitude is 1, that's up here. I should say the amplitude of the sine function. There is no amplitude for cotangent or tangent. One of these is 1 period. So again, the period here is pi. So this is going to be repetitive from what we had just done with tangents. The only difference is it's going the other way. So if you can just remember which direction they're going, that'll be a big part of this. If not, you can always plug a point into your scientific calculator and figure out which direction it goes. So we want to graph the cotangent function, and like we did before, I'm going to graph y equals 1/2 sine pi over 2x. Now keep in mind the sine comes from the fact that the cotangent is cosine over sine, and since the sine is in the denominator, my asymptotes are based on where the sine function goes to 0. So the amplitude is 1/2. Now that's the amplitude of the sine, not the cotangent. Cotangent doesn't have the amplitude. I have a b value of pi over 2. So therefore my period is 2 pi divided by pi over 2, or 4. So over here, this is going to be 4, 2, 1. That has to be 1, 2, 3. This is negative 1, if you will. Amplitude of 1/2. And again, notice that I keep using the same height. Doesn't really matter. As long as they're labeled correctly, we can read it. All right, so the sine function, if you remember, starts at the origin, goes up, comes back down, and we get these points right here. And I don't really need to draw the sine function. You can if you really want. What I'm looking for these points right here where I can plot my asymptotes. Asymptotes right there, there, and there. Not bad, pretty close. Let's get that adjusted. And from here, we're now going after the cotangent function. I know that this goes right here in the middle, halfway and up the amplitude, halfway down the amplitude, and this is a curve. This curve comes down through a nice smooth curve, approaches the asymptotes, halfway over, halfway down, and you've got your cotangent function. Don't make this any harder than it has to be. Period, remember, the period for cotangent here is half of the period for sine, so the period is 2. Notice that that was true from here to here was 2 units. So keep the difference between the period for the sine and the period for the cotangent, and see how they're related. Okay, the graph for the sine and the cosecant are also related, because we know that cosecant is equal to 1 over sine. So if I can graph the sine function, again, I can identify where it crosses the x-axis, here, here, and here. Those create asymptotes again, and I'm sort of working through this quickly just because it gets repetitive. You should probably play with this a little bit on a graphing calculator or Desmos. Desmos is actually probably easier to see. Come on, there we go. From there, once I have the sine graph and the asymptotes, the cosecant graph, and again, remember this is with a shift. The cosecant graph now is pretty straightforward. We're going to put a vertex literally right there, and it looks like a parabola. I put one right here. It looks like a parabola. We're done. This one up here, if you want another half one. Now, in this case, the period is going to be the same as the sine function. This went from negative pi over 4 to 7 pi over 4, which looks like it's going to be 2 pi, which we know because b equaled 1. So the period for the cosecant is also 2 pi, as well as for sine. All right, let's do this from the beginning. And again, I wouldn't worry too much about this stuff here. We'll fill those in as we need. So we are going to start by graphing y equals 2 secant 2x. Okay. With that, I know that my amplitude, I didn't say secant, did I really? All right, sorry you guys. I'm going to erase that because I didn't want secant. I wanted to cosine, because what's in the denominator of secant? Cosine 2x. My amplitude for the cosine is 2. My b value is 2. My period is 2 pi. Moving too fast. 2 pi divided by 2, or pi. So when I'm graphing this, I'm going to go 4 hash marks out is pi. Half of pi is pi over 2. Half of that's pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4 goes right here. And if you want negative pi over 4 in case that's needed, remember the amplitude was 2, so that's negative 2. All right, cosine graphs, hopefully we're getting pretty good at them. Remember, cosine starts high, comes down, down, back up, finishes up here at the amplitude. If you want to complete it, go ahead and plot one down here, as if you're going backwards. Now you have 3 asymptotes that you can plot easily. If I get them straight, readjust. Okay, so like we saw before, this is pretty easy from here. Once I have the asymptotes and I have the high points and low points, these things just approach the asymptotes. This one's going to go down. That wasn't very smooth, was it? There we go. If you wanted to, you could have one more over here or half of one. Okay, so I wouldn't worry about that. What I've just done is I've plotted one full period. Remember, the period was pi units. That works out. One up, one down. Okay, so let's just do one more, and I think we're done. Graphing a cosecant. Let's just go through this again, right? Y equals 2, not cosecant, but 1 over sine. So we're going to graph sine of 2x. My amplitude of the sine is 2. My b value is 2. My period, therefore, is 2 pi divided by 2, or pi. That allows me to label my x and y axis appropriately. We know this comes out here to be pi, pi over 2, pi over 4. Remember, half that. Now we can count by pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. By the way, what's 4 pi over 4? Yep, that's pi. If I want one backwards, negative pi over 4, amplitude of 2, negative 2. And you'll notice, again, these all look the same. Everything's labeled appropriately. The sine function starts at the origin, goes up, comes down, down, back up. If there was a reflection, all that would do is the asymptotes would be in the same place, but the cosecant parabolas will be switched. Asymptotes 1, 2, 3. Again, vertex approaching the asymptote. Not pretty, but it's done. Okay, one full period was pi units, 1 up, 1 down.